lesson, we are going to work on solving compound inequalities. But before we can solve compound inequalities, we need to learn what compound inequalities are and how to write them. It says here, compound inequality consists of two inequalities connected by and, or. We've solved inequalities something like this. X plus 5 is less than 7. Well, what a compound does is it says, the compound inequality says we have two inequalities. Right now, we just have one. X plus 5 is less than 7. A compound inequality is going to say, well, it's less than 7, but it's greater than -4. So a compound inequality is an inequality where we have two inequality symbols. And it can look like this, or sometimes we can say things like m is greater than 4, or m is less than -1. Okay, so compound inequalities, we're going to be talking about two inequalities kind of put together. Let's look at this example. The directions say to write an inequality that represents a set of numbers and sketch the graph. In part A here, we're talking about all real numbers that are greater than or equal to -2 and less than 3. And I apologize for my screen going black there for a second. So all real numbers that are greater than or equal to -2 and less than 3. Sometimes I find it helpful to kind of draw a graph. And since we have to sketch the graph anyway, it kind of works. All real numbers that are greater than or equal to -2. So here's 0, here's -2. If I'm going to focus on this here, and we're going to talk about all real numbers that are greater than or equal to -2, here's my -2, and we're going to talk about all the numbers greater than or equal to that. Okay, so I'm going to fill in the circle because it can be equal to -2. But we're also talking about the numbers less than 3. Well, if you look on your number line, here's 3, and we're going to talk about all the values less than 3. Now, what you want to focus on is the overlap. From here to here, even though my drawing is very, very messy, and I apologize, notice that we're talking about all the values in between here. We're saying we're talking about an x that pretty much has to be between -2 and 3. In fact, -2 has to be less than or equal to, it says it right here. So, I'm sorry, x has to be greater than or equal to -2, but it has to be less than 3. This is our compound inequality. All real numbers that are greater than or equal to -2, but still less than 3. Now, if we wanted to graph it, you kind of get a picture, an idea from here, but if I could try to make it a little bit neater, you don't want to continue this extra stuff out here. It can be greater than or equal to -2, but less than 3. And what I want you to notice on this graph is notice I filled in the circle here at -2 because it can be equal to -2, but I didn't at 3 because it's just less than 3. Okay, so there is our compound inequality, and here's our graph. Let's look at another example. We're talking about all real numbers that are less than or equal to -3 or greater than 0. Again, some of you may be able to look at that and just see the inequality. If you can't, try drawing a picture. Here's 0. Here's -3. We're talking about all real numbers that are less than or equal to -3. So if we're talking about real numbers that are less than or equal to -3, I'll draw my circle at -3, and I'm going to draw it to the left. Why the left? Because we're talking about the values less than -3. -4, -5, they're all smaller than -3. Or we're talking about the values greater than 0. Here's 0, and all the values greater than 0, that's going to go to the right. 1, 2, 3, 4, and so on and so forth. So we're actually talking about all the values to the right of 0. Now notice in this case our graph doesn't overlap. That's where that word or comes in here. Okay, notice here we had the word and this is an or statement. Compound inequalities consist of two inequalities connected by and or. So if you want to write this inequality, okay, we know our x value is going to be, or whatever variable, our real number is going to be less than or equal to -3, or x is going to be greater than 0. Okay, in this case, notice there is no overlap. We're not going to stick an x in the middle. We're talking about two distinct sets here, and that's why we use the term or. Okay, so again, it might be helpful to sketch a graph if you kind of get confused how to write the inequality. Let's look at these examples. It says write an inequality that describes each condition. It says water is a non-liquid when the temperature is 32 degrees Fahrenheit or below, or at least 212 degrees Fahrenheit. Okay, you could sketch a graph of this. You could say, all right, let's take this in two parts. It's a non-liquid when the temperature is 32 degrees Fahrenheit or below. Okay, so if I'll call it T. The temperature is 32 degrees or below. Well, I'm saying our 32 degrees our temperature has to be equal to 32 degrees or below it. So our temperature is going to be less than or equal to 32. That's what that means here. It's either going to be 32 degrees or below. Or, notice this key word here, it's at least 212 degrees. So if it's at least 212 degrees, I know it can equal 212, but are we talking about being smaller than 212 or greater than 212? Well, if it's at least 212, it means it has to be bigger than it. Okay, it has to be greater than 212. 200 is not at least 212, so we're talking about the values greater than 212. Now, again, if you were to sketch a graph, and you don't have to do this, okay, but here's 32, and we're talking about all the values below it. 212 is going to come way over here to the right on the number line, and we're talking about all the values greater than 212. There is no overlap. That's what that word or means there. So when we want to write an inequality, it's a compound inequality, we say the temperature is less than or equal to 32, or the temperature is greater than or equal to 212. Look at part B here. So the refrigerator is designed to work on an electric line carrying from 150 volts to 120 volts. So when you read this and you have to think of an inequality, you kind of think of it as it has to fall between 115 volts and 120 volts. It has to be at least 115. But it can't be any more than 120 volts. Okay, so in this case, it's an and statement. It has to be greater than 115, because it has to be at least 115, and less than 120. So this is what your inequality should look like. Okay? Again, if it's an and, it's kind of where we put the variable in the middle. If it's an or inequality, that's when we're talking about two sets going in opposite directions.